On this example, we have a satellite and some angles from the ground. So we have the path of a satellite orbiting the Earth causes it to pass directly over two tracking stations, A and B, which are 45 miles apart. So let's go bring that right down here. This is 45, right? From A to B, they just told us it's 45 miles apart. Okay. When the satellite is on one side of the two stations, here's the satellite up here. Yeah, this is the satellite. When it's on one side, right, it's to the right of the two stations. The angles of elevation at A and B are measured. So this is the angles of elevation. Why are they called angles of elevation? Because they're from the flat up. That's what an angle of elevation means. It means from horizontal up to the object, to looking at the satellite. And looking at the satellite, right? Okay, so that means that what would be helpful here, I think, is to draw the right side. So let's do that. Actually, you know what? Not right now. Never mind. We don't need that right now. Let's go on to their question. What is their question? We'll do that drawing in a minute. How far is the satellite from station A? So they want us to find this. Call it X. They want us to find out what this side is. X, because that's how far the satellite is from station A. How far is the satellite from station A? So it wants to find that, call it X. Okay, so how are we going to do it? Well, this is not a right triangle, right? It's not, let me write that up here. It's not a right triangle because I don't see any 90-degree angles right now. Not a right triangle, so we cannot use SOHCAHTOA, right? That's only for right triangles. So in a minute, we're going to make a right triangle when we do answer the second question about how high the satellite is above the ground, but for now, we don't have any right triangles. Okay, so what are we going to do then? Well, we're thinking law of sines or cosines. So the first thing we should do is find the missing angles. So, for example, let me back this, get rid of this a little bit here. Can I find this angle here? Yeah, it's got a total 180, doesn't it? So let me write. So step number 1, 180 minus 87.5 degrees. I'm going to use my calculator. I'm getting 92.5 degrees. So this right here, if I have room to write it, 92.5 degrees. I didn't make that 5 so nice. There we go. 92.5 degrees. That angle, this angle here must be 92.5 degrees. Why? Because together, you see, these two make 180. They're half of all the way around, aren't they? Right? You remember the unit circle, right? Halfway around is 180. So they together make 180 degrees. So you subtract from 180, the missing angle's got to be 92.5. Now we can find the top angle because remember every triangle holds 180. So the top angle is going to be 180 minus the other two angles added up, 84.1, and the new one we found 92.5. So the top angle, bring that down here a little bit. So the top angle has got to be whatever that is, 180 minus the other two added up. I'm getting 3.4 degrees. It's not a very big angle. 3.4 degrees. Right. So the top angle is 3.4 degrees. So this angle right here, this angle is 3.4 degrees. Or maybe it'd be better if I just, well, I'll just leave it like that. 3.4 degrees, right? Okay, now why is that so great? Well, now I have an angle and a side across from it. I can use law of sines. Remember, law of sines, when you have angle and opposite side, that's when you want to use law of sines. So step 3, coming on down here. Now we have top angle and opposite bottom side, don't we? We have the top angle up here and the bottom side across from each other. So that means you can set up a pair, right? Remember how that works? We can say this sine of the angle over the side, or side over the sine of the angle, and then what do we want to find? X, those two, right? Remember how the law of sines works? So use the law of sines. Remember the law of sines says you can take any side over the sine of the opposite angle. So I can take 45 over the sine of 3.4 degrees, right? See how that's these two? 45 over the sine of 3.4. That's got to equal x over the sine of 84.1. X over the sine of 84.1, because those are across from each other, aren't they? X and this angle. And this is x, what we're trying to find. So, law of sines, we're in business. Let's solve it. Cross multiply. 45 sine 84.1 degrees is x sine 3.4 degrees. Finish solving for x. Divide by the sine of 3.4 degrees. Cancels. X is alone. What is it? 45 sine of 84.1 divided by sine of 3.4. I'm getting x is 754.7523. 75223. It actually rounded to 24. Now, how many? I don't know how many decimals they wanted. I didn't see it anywhere, so I'll write that in. So we get 754.7524. 7524. Okay, that's A. Now, part B, or the second part. How high is the satellite above the ground? Okay, so let's go draw that on our diagram. So that's going to be, let me go from right here, the very top, straight down. Does that look straight down? And maybe not quite. Yeah, maybe that's straight down. That is height, isn't it? It's got to be 90 degrees here, doesn't it? Why? Well, because that's how we measure height. That's the very meaning of height. If you go to measure your height, you can't go diagonally down to the ground. You'd be ready for the NBA, right? Height has to go straight down to the ground at 90 degrees, doesn't it? That's the very meaning of height. So when they ask us what's the height of that satellite, they're saying go straight down to the ground. So, okay, so why is that so great? Well, that means we've made a little bitty, see if I can do this better here, a little bitty right triangle, you see. That little thing I just shaded is a right triangle because it goes straight down to the ground. So that's a little bitty right triangle, so I can use SOHCAHTOA, right? Do you see that? And specifically, the what am I trying to find? The height. Call this H, and then I have this angle here, right? 87.5. So this side here is the opposite, and this is the adjacent, and this side here is the hypotenuse. This X, which I just found, is the hypotenuse of that little bitty highlighted right triangle. It's got a right angle. I can use SOHCAHTOA. So what trig function involves opposite, which I'm trying to find, and hypotenuse, which I have? Opposite hypotenuse, sine. So for the final step here, this will be step number 4. Maybe I can squeeze it in right here where we can see the triangle. So step number 4, sine of the angle 87.5 degrees is going to be opposite over hypotenuse. So that means sine of 87.5 degrees. Oops, kind of scribbly there. Sine of 87.5 degrees, this angle right here, is opposite height over hypotenuse x, which is the side I just found, right? That x is the 754. That's the distance from A. That's what we just did all that work to find. 754.7524. So we can use that to solve for h. Put this over 1, diagonal, diagonal. So h times, I'm going to run out of room here for sure, h times the sine of 87.5 degrees. No, what am I doing? That's h times 1, isn't it? Right, these guys multiply. So 1 times h is 754.7524 sine of 87.5 degrees. 1 times h is just h. So h equals, let's figure it out. I'm getting 754.034. Yeah, it's not much different. It's a little shorter than the other h, but not much. So, than the other x. 754.034. I don't know how many digits. Oh, 2. I should have read the fine print. So 2 digits. 754.03. The other one would be 0.75. So they're close, but slightly different, aren't they? That many miles. So they're close because the other one's at 87.5 degrees. It's almost 90 degrees down to this point here. Right? This angle here is at 87.5. The other one's straight down at 90. It's a little closer, 754.03.